Okay, so in this video, I'm going to go through how we measure these ECG complexes for both a dog and a cat. The dog ones are going to come up first for you guys. So this is the first ECG strip that we'll be looking at. Make sure you look at it and you realize that it was ran at 10 millimeter per millivolt calibration and 50 millimeter per second paper speed, as you will need to know those for the following slides. So before we get completely started measuring the heart rate, I do want you guys to notice that there is an arrhythmia on this ECG strip. The heartbeats are not coming in a rhythmic pattern, and there is also this wave right here that is most likely a P wave, and there is no QRS. So a P wave with no QRS is going to be a second degree AV block scenario. So now measuring heart rate for this one. You guys can see that I've drawn this out for you. This is at 50 millimeters per second. So we know that every 50 millimeters that goes by, 1 second of time will have passed. Each tiny box on this is worth 1 millimeter. And each of those larger boxes where you can see I've drawn out my little dots, those are going to be 5 millimeters. So if you guys remember from in class, I talked about counting by fives, 5, 10, 15, 20, all the way up until you get to 50. And I block it out in 1 second segments, and I count up to 6 if I can get there. And then we go back and we count the number of R waves. So here I had 1, 2, 3, 4 R waves in 6 seconds. 4 times 10 equals 40 beats per minute. So in this slide, I've kind of traced out for you guys some of the vertical measurements. The P wave is for you in red, and the R wave is there for you in blue. And I drew out in yellow for you guys the PR segment. That's really important to know because that's always going to be your baseline. So from your baseline is where you're going to measure how tall the different waves are. So in this one, I've gone through and I've done that different math for you. So you can see over here I have the P wave, 2 small boxes, 2 millimeters, using that calibration factor of 1 millivolt to 10 millimeters to 1 millivolt, we get 0.2 millivolts for our P wave. Likewise up here, we have the height of the R wave, started from that PR segment, counting up to the tip. Over here for you, 1.4 millivolts. Again, measuring the height of the T wave from the PR segment and going up, we have a height of 2 small boxes, so 2 millimeters for that T wave as well. So here on this slide, I've drawn out for you the sort of parts of the PR and the PR segment and interval for you guys. You can see where I have the P wave in red for you, the PR segment in blue, and the PR interval in green. And remember, it is hard to get these exact, and I've blown this up really big for you guys. So when it's on a smaller scale, you're not going to be able to count things down to like 1/4 of a box or 3/4 of a box. Sometimes you can get half a box. That's good enough. You don't have to give me anything more exact than that. Also remember, on any test, I always give you guys a leeway of a box or 2, depending on what the different wave that you're measuring is. So don't worry that you're a half a box off, because if you're within half a box of the correct answer, you're going to get the answer right. So on this slide, I've drawn out for you some more of the horizontal measurements. Remember, when we're doing horizontal, we're using that paper speed to figure out how many seconds something has taken. So here I have for you the P wave, the QRS complex, the QT interval, as well as the ST segment. So take a look at those, make sure that's making sense for you on where and how we kind of count these. Again, if you're a box or 2 off, it's not going to be the end of the world. You will most likely still get the answer correct. You can always look at the normals that I gave you guys in that ECG packet to see if you're in the ballpark. And if you're way off, maybe then you want to go back and double check that what you've done makes sense. So here is our cat ECG. These are a little bit harder to measure, but we can still make sense of all of this. One thing I want to point out for you guys on this one is, again, making sure that you've looked and you see that this is now at 20 millimeters per millivolt, still at 50 millimeters per second. And remember, if the calibration isn't written for you, if for some reason this were cut off on your sheet, but you have this calibration marker, you can tell this is 5, 10, 15, 20. This is 20 millimeters per millivolt within that calibration rectangle. Here's the heartbeat on this cat. Note for here I gave us a start line and where my finish line was going to be. This one I wasn't able to get to 6 seconds. I only got to 3 seconds before I ran out of ECG paper. So here I started 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 1 second. 50 millimeters, 50 millimeters, 50 millimeters. 1 second, 2 seconds, 3 seconds. I'm going to count my R waves. 1, 2, 3, 4, 5, and 6. 6 R waves because I only had 3 seconds. I'm multiplying by 20 to get 180 beats per minute. And here's sort of the color-coded horizontal measurements for you guys on this cat. You can see I sort of have them color-coded, so if you're looking for your P wave, it's going to be in yellow and following the similar colors. I didn't show you guys the math for every single one, but it's the same as what I showed you for the P wave. So for the PR segment, you'd have 3 millimeters. It would be 3 divided by 50, which is going to give you the 0.06 seconds. So take a look at this one, and hopefully it's starting to make a little bit more sense for you guys. So here on this slide, I'm showing you those vertical measurements. Again, remember, we always start from baseline, which is our PR segment. So starting from baseline, measuring up for our P wave, we get 2 millimeters. Starting for our R wave, we're going to get it up to 5 millimeters, and for the T wave, I got 1.5 millimeters. For these ones, we needed to use that calibration factor of the 1 millivolt per 20 millimeters.